They called it a reconnaissance vehicle. The official designation was Light Tank M24, named Chaffee, after General Adner Chaffee, the father of the U.S. Armored Force. But the men of the 2nd Cavalry Group, who first took them into combat in December of 1944, knew what they really were: targets. The Chaffee weighed 18 tons, carried armor no thicker than 25 millimeters at its thickest point, and mounted a 75 millimeter gun that American tankers had learned to distrust after years of watching their shells bounce off German heavy armor. When intelligence reports indicated Tiger tanks in the sector near the German border, the reaction among Chaffee crews was not confidence. It was resignation. A Tiger weighed 60 tons. Its frontal armor was 100 millimeters thick, sloped and hardened to defeat the best anti-tank weapons the Allies possessed. Its 88 millimeter gun could penetrate any Allied tank from ranges exceeding a mile. In 3 years of combat across North Africa, Italy, and France, the Tiger had earned a reputation that bordered on mythological. Allied tankers told stories of Tigers shrugging off dozens of hits, of entire tank platoons destroyed by a single Tiger firing from concealment, of armor so thick that only direct hits from heavy artillery or tank destroyers had any hope of penetration. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The men climbing into Chaffees that winter knew these stories. They had heard them from Sherman crews, from tank destroyer units, from infantry who had watched Tigers methodically dismantle American armor during the fighting in Normandy. The standard tactical doctrine when encountering a Tiger was simple: withdraw, call for air support or heavy weapons, do not engage directly. A light tank encountering a Tiger was not expected to fight. It was expected to run. But in the forests along the German frontier in December of 1944, running was not always possible. The terrain was broken, the roads few, the German defenders determined. And in a series of small, desperate engagements that would be largely forgotten in the chaos of the Battle of the Bulge, American crews in their light Chaffee tanks discovered something that German Tiger commanders had never considered. Invincibility is an illusion that depends entirely on which part of the armor you're shooting at. The story of how they learned this, and what it cost, begins not with American light tanks, but with German confidence built over years of combat success. The Tiger tank entered service in August of 1942 on the Eastern Front near Leningrad. The Soviet offensive had pushed German forces back through the summer, and Wehrmacht commanders desperately needed a weapon that could stop the increasingly effective Soviet 34 medium tanks. The Tiger was Germany's answer, a breakthrough tank designed to engage enemy armor at long range while remaining immune to return fire. The technical specifications were impressive by any standard. The tank measured 6.3 meters long, 3.7 meters wide, and 3 meters tall. The weight of 57 tons empty, reaching 60 tons fully loaded with crew, fuel, and ammunition, made it one of the heaviest tanks in operational service anywhere in the world. The power plant was a Maybach HL, 230 P45 gasoline engine producing 700 horsepower at 3,000 revolutions per minute, giving the Tiger a top speed of 38 km per hour on roads and approximately 20 km per hour cross-country. The armor protection was unprecedented. The frontal hull armor was 100 millimeters thick, vertical rather than sloped. The turret front was 100 millimeters thick. The side armor was 80 millimeters. Even the rear armor was 80 millimeters, thicker than the frontal armor of most Allied tanks. The armor was high-quality, face-hardened steel, manufactured to exacting specifications at German steel plants that had been perfected over decades of industrial development. The main armament was the 8.8 cm KBUK 36L 56 gun, a long-barreled, high-velocity weapon derived from the famous 88 mm anti-aircraft gun that had proven so effective in an anti-tank role in North Africa. The gun could fire armor-piercing rounds at a muzzle velocity of 810 meters per second, giving it penetration capability that exceeded any Allied tank gun in service in 1942. At 1,000 meters, the Tiger's gun could penetrate 100 to 32 millimeters of armor plate. At 2,000 meters, it could still penetrate 110 millimeters. The combination of heavy armor and powerful armament created a tank that could engage Allied armor from ranges where Allied guns were ineffective, while remaining largely immune to Allied fire. The psychological impact was immediate and profound. Soviet tankers reported Tigers engaging 34s from positions so distant the Soviet crews could barely see them, destroying tank after tank before the Soviets could close to effective firing range. When Tigers deployed to Tunisia in North Africa in December of 1942, British and American forces encountered the same brutal reality. On February 14, 1943, near Sidi Bouzid, Tigers, from the 501st Heavy Panzer Battalion, engaged American M24 Sherman medium tanks at long range. The results were devastating. American 75mm guns could not penetrate the Tigers' frontal armor at combat ranges. British 6-pounder anti-tank guns were equally ineffective. Only by maneuvering to the Tigers' flanks or rear, where the armor was slightly thinner, did Allied crews have any realistic chance of penetration. The Tigers' success created a problem that would haunt German tank development for the rest of the war. It convinced German designers that heavier armor and bigger guns were the solution to every tactical challenge. When Allied tanks improved, Germany responded by designing even heavier tanks. The Panther, introduced in 1943, weighed 45 tons. The Tiger II, which entered service in 1944, weighed nearly 70 tons. The doctrine became fixed. Build tanks that could destroy any enemy vehicle at long range while remaining invulnerable to enemy fire. This philosophy had an internal logic. German tank commanders who survived combat in Tigers reported feeling genuinely safe inside their vehicles, a sensation almost unknown to tankers on any side of the war. The armor worked. It stopped shells that would have penetrated any other tank. Crews trusted their protection, and that trust affected their tactical decisions, their willingness to engage superior numbers, their confidence in holding defensive positions against overwhelming odds. Lieutenant Otto Carius, who commanded Tigers with the 502nd Heavy Panzer Battalion on the Eastern Front, later wrote about the psychological comfort of Tiger armor. He described engaging Soviet tanks from positions where return fire was constant and heavy, watching shells strike his tank's frontal armor and bounce away without penetrating, knowing that his crew was safe as long as they maintained frontal protection toward the enemy. The Tiger crews developed tactics around this invulnerability: engage at maximum range, keep frontal armor toward the enemy, use superior optics and gunnery to destroy threats before they could maneuver to flanking positions. By 1944, these tactics were doctrine, taught to every Tiger crew during training. The tank's reputation had spread throughout the Wehrmacht. Being assigned to a Tiger unit was considered a privilege, a guarantee of survivability that crews in Panzer IVs or even Panthers did not enjoy. The Tiger was the ultimate defensive weapon, capable of holding critical sectors against overwhelming numerical superiority through sheer firepower and protection. But this confidence, this trust in armor protection, contained an assumption that few German commanders questioned: that enemy fire would come from the front, from guns roughly at the same height as the Tiger's own gun. Following the traditional geometry of tank versus tank combat, the Tiger's design reflected this assumption. The frontal armor was massive, carefully angled to maximize effective thickness. The side armor, while still heavy by Allied standards, was thinner because enemy fire from the flanks was considered less likely in defensive operations. And the top armor, the roof plates protecting the crew compartment and engine deck, was thin. Very thin. Just 25 millimeters over the turret, 16 millimeters over the hull. This was not a design flaw in the traditional sense. Top armor on almost all tanks was thin because overhead threats, aircraft bombs or artillery airbursts, were relatively rare, and making the roof armor thick would add weight that compromised mobility and mechanical reliability. German engineers calculated that 25 millimeters was sufficient to stop shell fragments and small-caliber aircraft gunfire. They never seriously considered that enemy tanks might shoot at the top of the Tiger, because in normal tank combat, tanks shoot at each other across roughly level ground. A 75mm tank gun fires on a nearly flat trajectory. Its shells travel horizontally, striking vertical armor plates on the front or sides of enemy vehicles. The geometry of tank combat in open terrain, the primary environment where Tigers operated, made overhead fire essentially impossible. But in December of 1944, along the forested ridges and steep valleys of the German frontier, the geometry was about to change. The M24 Chaffee was never intended to fight Tigers. The tank's development began in April of 1943, when the US Armored Force recognized that its existing light tank, the M5 Stuart, was becoming obsolete. The Stuart mounted a 37mm gun that was inadequate against German armor encountered in North Africa and Sicily. American planners wanted a light tank with better firepower, while maintaining the mobility and reliability that made light tanks valuable for reconnaissance and exploitation operations. Cadillac Motor Car Division, which had designed the M5 Stuart, received the contract to develop the new light tank. The design team faced contradictory requirements: increase firepower without significantly increasing weight, improve armor protection without sacrificing speed, maintain mechanical reliability while incorporating a larger gun and turret. The solution was a complete redesign rather than an incremental improvement. The M24 used a new chassis with torsion bar suspension, a system that provided better ride quality and easier maintenance than the vertical volute spring suspension used on earlier American light tanks. The hull was welded armor plate rather than riveted construction, eliminating a weak point where rivets could be driven into the crew compartment by shell impacts. The turret was designed to mount the 75mm M6 gun, a lightweight weapon specifically developed for the light tank role. The M6 gun was not the same weapon mounted in Sherman tanks. The Sherman's 75mm M3 gun had a barrel length of 40 calibers and fired standard ammunition at relatively modest velocities. The M6 gun had a shorter barrel, just 39 calibers long, and generated lower chamber pressures to reduce the recoil forces that the light tank's suspension and turret ring had to absorb. The ballistic performance was inferior to the Sherman's gun, with armor-piercing rounds, achieving a muzzle velocity of only 619 meters per second, compared to the Sherman's 619 meters per second. This meant the Chaffee's gun could not penetrate heavy German armor frontally at combat ranges. Against a Tiger's 100mm frontal armor, the M6 gun firing standard armor-piercing ammunition had effectively zero chance of penetration beyond point-blank range. Against a Panther's 80mm sloped frontal armor, the situation was equally hopeless. American ordnance officers knew this when they approved the design. The Chaffee was not a tank destroyer. It was a reconnaissance vehicle with enough firepower to handle enemy light vehicles and support infantry operations. The first M24 tanks arrived in Europe in November of 1944, issued initially to cavalry reconnaissance units rather than armoured divisions. The 2nd Cavalry Group, operating with the 3rd Army in eastern France, received Chaffees in late November. Crews transitioning from M5 Stuarts appreciated the improved firepower and better crew accommodations. The Chaffee had a 5-man crew with proper positions for each member, far more comfortable than the Stuart's cramped 4-man arrangement. The 75mm gun gave reconnaissance units the ability to engage German defensive positions and light armor without immediately calling for support. But crews were explicitly warned about the tank's limitations. Training emphasized that the Chaffee was thinly armored and should avoid direct engagement with German medium or heavy tanks. The frontal armor was 25mm at its thickest point on the turret mantlet. The hull front was 25mm, but only on the upper glacis plate. The lower hull was just 19mm. Side armor was 25mm on the turret and 19mm on the hull. The armor was rolled homogeneous steel, not face-hardened, providing uniform resistance, but no special protection against armor-piercing rounds. A German 88mm gun could penetrate the Chaffee's frontal armor from well over 2,000 meters. A Panther's 75mm gun could do the same. Even the long-barreled 75mm guns, mounted on late-model Panzer IV tanks, could defeat the Chaffee's armor at combat ranges. American tankers understood that their survival depended on not being seen, on using mobility and reconnaissance to avoid direct combat with German armor. In early December of 1944, the 2nd Cavalry Group moved into positions along the Saar River sector, patrolling between American infantry units and conducting reconnaissance missions into contested territory. The terrain was difficult: steep wooded ridges cut by narrow valleys, small villages clustered along roads that wound through forested hills, limited visibility even in good weather. It was reconnaissance country, where light tanks could operate in terrain too restrictive for heavy armor, using speed and agility to avoid decisive engagement. The engagement that would change everything occurred on December 23, 1944, near the village of Sinz in the Saar-Moselle Triangle. The location was not strategically significant, just another small German border village that American forces needed to clear as part of the broader advance toward the Siegfried Line fortifications. The 2nd Cavalry Group's F Troop had been ordered to probe German defenses and determine enemy strength in the sector. 3 M24 Chaffees moved cautiously through the approach to Sinz in the early afternoon. The lead tank was commanded by Staff Sergeant Paul Faircloth, a veteran of the North African and Italian campaigns who had transitioned from Stuarts to Chaffees only 3 weeks earlier. His crew consisted of Corporal James Mitchell as gunner, Private First Class Robert Hayes as loader, Private First Class William Carson as driver, and Private First Class Thomas Webb as assistant driver and bow gunner. They had worked together for 6 months and trusted each other's competence under fire. The road into Sinz descended into a shallow valley with wooded slopes on both sides, rising approximately 50 meters above the valley floor. The December weather was cold and overcast, with patches of snow on the ground under the trees. Visibility was limited by the terrain and by the bare trees that still provided visual concealment. Faircloth stood in his commander's cupola, using binoculars to scan the tree line ahead, looking for signs of German defensive positions. At 1430 hours, German machine gun fire erupted from positions on both sides of the road. The tracers came from multiple positions, indicating a prepared defensive line. Faircloth dropped into the turret and ordered his driver to reverse, the standard reaction when reconnaissance encountered prepared defenses. But, before Carson could shift into reverse gear, a massive explosion struck the ground 10 meters ahead of the lead Chaffee. The shell was 88mm high explosive, fired from a Tiger tank positioned on the ridge to the north of the valley. The Tiger was approximately 600 meters from the American tanks, positioned hull down behind earthworks that exposed only its turret. The German commander had waited until the American column was fully committed in the valley before opening fire, a textbook ambush in terrain that limited the Americans' ability to maneuver. Faircloth recognized the sound of an 88 immediately. Every tanker in Europe knew that distinctive crack of the high-velocity gun. His training and every tactical instruction he had received said the same thing. Withdraw immediately. Do not engage. Call for support. But the terrain made withdrawal problematic. The road behind them was narrow, bordered by drainage ditches that would bog down a tank. Reversing in column meant the trailing vehicles would have to back up blind for hundreds of meters before reaching ground where they could turn around. The Tiger fired again. The second round struck the road surface between the 1st and 2nd Chaffees, throwing mud and rock fragments against both vehicles. The German gunner was ranging in, walking his fire onto target with the methodical precision of a well-trained crew. The next shot would likely hit. Faircloth made a decision that violated his training, but followed the logic of the immediate tactical situation. The Tiger was hull down on high ground, exposing only its turret and gun. From the Chaffee's position in the valley bottom, the angle of fire was not horizontal as in normal tank combat. It was upward, roughly 15 to 20 degrees above the horizontal, aiming at the elevated German position. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. He ordered Mitchell to traverse the turret toward the Tiger's position and load armor-piercing ammunition. Mitchell protested, pointing out correctly that their 75mm gun could not penetrate a Tiger frontally. Faircloth shouted over the intercom, "We're not shooting at his front. Aim for the top of the turret." The geometry of the engagement created a firing solution that would have been impossible on level ground. The Tiger on the ridge was approximately 50 meters higher in elevation than the Chaffees in the valley. To engage the elevated target, the M24's gun had to elevate significantly, creating a trajectory that brought the shell down on the Tiger, not from the horizontal but from above, striking surfaces that were never designed to resist direct fire from tank guns. Mitchell elevated the gun barrel to maximum elevation, approximately 20 degrees, and aimed at the Tiger's turret through his telescopic sight. The range was 600 meters, relatively close for tank combat but not point-blank. At that range, the M6 gun's armor-piercing round retained most of its kinetic energy, striking with sufficient force to penetrate steel armor up to approximately 60 millimeters thick under ideal conditions. The top of a Tiger's turret was protected by 25mm armor plate. This was calculated to stop shell fragments and light-caliber aircraft gunfire, not direct hits from tank guns. German designers had never anticipated that enemy tanks would shoot at the turret roof because in normal combat geometry, such shots were impossible. Mitchell fired. The 75mm armor-piercing round struck the Tiger's turret roof near the commander's cupola. At impact, the round was traveling at approximately 570 meters per second, having lost some velocity over the 600-meter flight path. The kinetic energy was sufficient to punch through the 25mm armor plate, cleanly. Inside the Tiger, the effect was catastrophic. The armor-piercing round penetrated the roof, passed through the turret interior at high velocity, and struck the floor of the fighting compartment. The round did not explode. Armor-piercing ammunition relies on kinetic energy rather than explosive filler. But the penetration created metal fragments from the armor plate itself, fragments that ricocheted through the cramped interior at lethal velocities. The German loader, standing in the left side of the turret, was struck by multiple fragments and killed instantly. The commander, positioned in the cupola directly above the point of impact, was severely wounded. The Tiger's return fire stopped immediately. German tankers surviving the hit reported later during interrogation that the crew abandoned the vehicle within seconds of the penetration, dragging their wounded commander through the turret hatch and running for cover in the tree line. The Tiger remained in position, silent, and smoking slightly from the engine exhaust, its gun no longer traversing to follow targets. Faircloth ordered his driver forward. The tactical situation had reversed in seconds. Instead of withdrawing from an untenable position, they were now advancing on a disabled enemy tank. The second and third Chaffees in the column followed, moving toward the ridge where the Tiger sat immobile. As they climbed the slope, additional German machine gun fire came from infantry positions, but no more tank fire. The Tiger had been alone, positioned to ambush American armor in the valley below, operating on the assumption that its armor made it invulnerable to light tank fire. When American troops reached the Tiger's position an hour later, after clearing the surrounding infantry, they found the tank abandoned with the engine still running. The crew had not taken time to shut down properly before evacuating. On the turret roof, there was a clean hole approximately 75 millimeters in diameter where the American shell had penetrated. Inside, the damage was extensive. Blood covered the floor and the loader's position. Armor fragments from the internal surface of the roof plate had scarred every surface in the fighting compartment. The engagement near Sinz was not unique. As American forces pushed into German border regions through December of 1944 and into January of 1945, similar encounters occurred wherever the terrain created elevation differences between opposing forces. Tank destroyers and Shermans operating in hilly or mountainous terrain discovered the same vulnerability. German heavy tanks positioned on high ground could be engaged from below with trajectories that struck their thin roof armor. Reports from units in the Ardennes during the Battle of the Bulge documented multiple instances of Tiger and Panther tanks disabled or destroyed by hits to their top surfaces. In one engagement near Bastogne on December 26, 1944, an M10 tank destroyer firing from a valley bottom struck a Panther positioned on a ridge. The 3-inch armor-piercing round penetrated the engine deck armor, only 16 millimeters thick, and disabled the power plant. The crew abandoned the vehicle, believing they had been hit by aircraft rockets, not realizing that ground fire from below had found their weakest point. American tactical doctrine began to incorporate these lessons by January of 1945. Training materials distributed to armored units emphasized that engaging German heavy tanks from positions of lower elevation could be effective, particularly at ranges under 1,000 meters, where guns retained sufficient penetrating power. The guidance specified aiming points: turret roofs, engine deck covers, and the commander's cupola, all protected by armor ranging from 16 to 25 millimeters thick. For Chaffee crews, this knowledge transformed their tactical relationship with German armor. They were still outmatched in any conventional engagement where geometry followed normal patterns. A Tiger or Panther on level ground remained effectively invulnerable to the M24's gun from frontal aspects. But in terrain that provided elevation advantage to the lighter American tanks, or in situations where they could maneuver to positions below German armor on high ground, they had a fighting chance. The psychological impact was significant. Crews who had accepted that their role was reconnaissance and avoidance now understood that under specific circumstances they could engage and destroy the most feared German tanks. This knowledge affected their tactical decisions, their willingness to press reconnaissance missions into defended territory, and their confidence when operating in difficult terrain. The Chaffee remained a light tank with thin armor and limited firepower, but it was no longer simply a target waiting to be destroyed by German heavy armor. German responses to this vulnerability were limited by the stage of the war. By early 1945, Germany's industrial capacity was collapsing under strategic bombing and resource shortages. Redesigning existing tanks to add roof armor was impossible. The Tigers and Panthers in service would fight with the armor protection they had, accepting the newly discovered vulnerability as an unavoidable weakness. Some German units modified their tactical deployment to minimize exposure to fire from below. Commanders were instructed to avoid positioning tanks on exposed ridgelines where American forces in valleys could engage them from lower elevations. But the terrain often dictated positions, particularly in defensive operations where controlling high ground was essential. German tankers had to accept that their armor, previously considered near invulnerable, had weak points that Allied forces were learning to exploit. The disparity between German and American approaches to tank warfare became increasingly apparent through the final months of the war. Germany had invested in quality, heavy tanks with thick armor and powerful guns, technically sophisticated but expensive to produce and difficult to maintain. A single Tiger cost approximately 800,000 Reichsmarks and required approximately 300,000 man-hours to manufacture. Production peaked at approximately 100 Tigers per month in mid-1944, then declined as factories were bombed and materials became scarce. The United States had invested in quantity and operational sustainability. The M24 Chaffee cost approximately $55,000, required far fewer man-hours to produce, and could be manufactured at much higher rates. More importantly, American doctrine emphasized combined arms operations where light tanks worked with infantry, artillery, tank destroyers, and air support, rather than attempting to win tank versus tank duels through superior armor and firepower alone. By March of 1945, as Allied forces crossed the Rhine and drove into Germany's interior, encounters between Chaffees and German heavy tanks became increasingly rare. The Wehrmacht's armoured forces were depleted, with surviving Tigers and Panthers concentrated in shrinking defensive perimeters or abandoned for lack of fuel. The Chaffee continued in its intended role: reconnaissance, exploitation of breakthroughs, support for infantry operations in terrain unsuitable for heavier armour. But the crews who had fought in them during the winter battles carried knowledge that shaped their understanding of armoured warfare. They had learned that invulnerability is always conditional, dependent on specific tactical circumstances and enemy capabilities. The Tiger's reputation, built on 3 years of combat success, had been based on a particular combat geometry: tank guns firing horizontally at vertical armor surfaces. Change the geometry, and the invulnerability disappeared. This lesson extended beyond the specific case of German heavy tanks. It applied to all military technology, all tactical doctrines built on assumptions about how combat would unfold. Equipment designed for one set of conditions might prove vulnerable when conditions changed. Armor that stopped every threat in testing might fail against unconventional angles of attack. Tactical confidence based on past success could become dangerous overconfidence when enemies adapted their methods. German Tiger crews who survived the war and later discussed their experiences expressed a consistent theme: betrayal. They had been told their armor made them safe, that their tanks could withstand anything the enemy fired at them. This belief shaped their tactics, their willingness to accept certain missions, their confidence in holding defensive positions. When they discovered that relatively light American guns could penetrate their roof armor, killing crew members inside what was supposed to be an impregnable fortress, the psychological impact was profound. One former Tiger commander, interviewed decades after the war, described the moment he learned that American light tanks had knocked out Tigers by shooting at their tops. His first reaction was disbelief. It seemed impossible that a reconnaissance vehicle mounting a gun inadequate for normal tank combat could threaten a Tiger. But the evidence was undeniable. Knocked out Tigers with penetrations through their roof armor were documented in after-action reports, photographed by intelligence officers, examined by technical teams assessing German equipment. The commander described feeling a sense of fundamental disorientation. If the armor could be defeated by light tanks exploiting terrain, what other assumptions were wrong? What other confident assessments of German technical superiority were based on incomplete understanding? The experience, he said, mirrored Germany's broader situation by early 1945. Discovery that what they had believed about their capabilities and their enemy's limitations was fundamentally mistaken. For American forces, the experience reinforced lessons they had been learning throughout the war. Technical sophistication and individual superiority mattered less than tactical flexibility and willingness to adapt. The Chaffee was not a better tank than the Tiger by conventional metrics. It was lighter, more weakly armored, and less powerfully armed. But in specific tactical situations, with crews willing to exploit terrain and attack from unconventional angles, it could achieve results that seemed impossible based purely on technical specifications. This philosophy, emphasizing adaptability and combined arms operations over reliance on superior individual platforms, would characterize American armored doctrine for decades after the war. The experience of light tanks defeating heavy tanks through tactical innovation rather than technical superiority validated an approach to warfare that prioritized operational flexibility over engineering perfection. The M24 Chaffee continued in American service through the immediate post-war period and into the Korean War, where it saw extensive combat against North Korean and Chinese forces from 1950 to 1953. By that time, it was obsolete by the standards of modern tank design, but it remained effective in reconnaissance and infantry support roles. The lessons learned in its combat debut against German armor informed how American forces employed it, as a mobile, adaptable platform for combined arms operations rather than a vehicle designed for tank versus tank combat. The Tiger, by contrast, disappeared from history shortly after the war's end. The few surviving examples became museum pieces or were scrapped for metal. The design philosophy it represented, building heavy tanks optimized for frontal engagements with maximum armor and firepower, was abandoned by post-war tank designers in favor of more balanced approaches emphasizing mobility, mechanical reliability, and tactical flexibility. But the engagement near Sinz in December of 1944 remained instructive for anyone studying armored warfare. It demonstrated that vulnerability exists in every design, often in places designers never considered because they assumed certain types of attack were impossible. The Tiger's thin roof armor was not a design flaw in the conventional sense. It was a calculated trade-off based on reasonable assumptions about combat geometry. Those assumptions proved incorrect when terrain and tactics created firing solutions that had not been anticipated during the design phase. For the crews involved, both American and German, the engagement represented a moment of revelation. American tankers discovered that their supposedly inadequate light tanks could engage and destroy the most feared German armor under specific circumstances. German tankers discovered that their trusted armor had vulnerabilities that negated its protective value when enemies adapted their tactics. These were small tactical lessons learned in minor engagements that barely rate mention in comprehensive histories of the war. But they captured essential truths about industrial warfare between modern nations. Technical superiority in individual platforms mattered less than adaptability and willingness to exploit enemy weaknesses. Confidence in equipment's protective capabilities could become dangerous when based on assumptions about how combat would unfold. And the gap between designed performance and actual battlefield effectiveness was often determined by factors designers never anticipated: terrain, tactical innovation, and the desperate ingenuity of crews fighting for survival. The Tiger tanks that hunted American light armor through the winter of 1944 believed their armor made them invulnerable. They positioned themselves on high ground, confident that their thick frontal armor would stop any American gun. And they discovered, in a few brief, violent encounters, that invulnerability is always an illusion that depends on which direction the enemy is shooting from. For the Chaffee crews firing upward from valley floors, watching their shells penetrate armor that should have been impenetrable, the lesson was equally clear. In war, geometry matters as much as technology. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.